Whew. I think this video is actually long overdue. I've always wanted to talk about this a long time, but I feel like I have actually not had the necessary experience to do it. But I think now I think I have a sufficient level of knowledge to explain certain things to people, and this actually applies to people that are very new, trying to get into IT, trying to get into cloud. Yeah, a lot of people are trying to get into cloud. And there are a few things that we need to clarify, right? So I think you need to understand what cloud is it's all about itself. So the goal today is to break down cloud itself, right? Especially people that say, "Oh, I want to do AWS. I want to do AWS and all that." So first of all, AWS is not the only cloud service. Take that out of your mind if you already have that in your mind. We have other cloud service like Azure. Another one is GCP, Google Cloud by Google. We have another one by IBM, and we have other ones that I can't even remember on top of my head. So understand that those are different type of cloud services. They are all computing services, and offered by AWS is specifically offered by Amazon. IBM is by IBM. Azure is by Microsoft. Google is by Google. And one thing you have to also understand is the fact that being a cloud engineer or being a cloud architect or being a cloud developer does not make you a software engineer. No, you're not a software engineer. Software engineers are completely different type of people. Now, I'll give you the relationship between software engineers or web designers. Is it web designers? Web developers, yeah, web developers or front end developers or even UI UX designers. That those are like different part of IT that don't even really have anything to do much with cloud. So cloud is really more like a platform or like a compute service that is being offered to probably host the things or to house the things software engineers are building. So it took me a little while to actually bring this relationship together, and that's because I never got the right guidance, and you're probably in that same boat, but we can break that myth today. So I'm going to give a very good example and try to follow along, try to like intuitively like understand, like put your mind together, take a deep breath. I'm going to walk you through this journey. Okay, so I'll give a very good example. So I would think what an application would be like. Building an application is nothing but just how do I say it, it's it's tough to explain what an application is. I'm so terrible. I don't want to use dictionary or something, but think about an application that can, and an example of an application is you go to amazon.com. That's an application. It's a web application. It can also be on a mobile, it can also be a mobile application. Anything that you go to access wherever in the cloud that works and you interact with, it's an application. No matter how simple, no matter how complex, it's an application. Now, the first stage of developing the application is you have the software developer, and that is not just, even saying the word software developer is might still be vague. You might want to be specific about backend. I'm not going to go into those. It's not my area, but I understand how it works. We have the backend, we have the front end, we have the UI UX. We probably have a full stack person who can do both backend and front end. But the idea is that they are building something. They have their computer, they have their laptops. They're building it on top of that laptop. Whatever language they are using, whatever stack they are using, is up to them. They're building it. Now, at the end of the day, once they're done building whatever they're building, they can access it on their laptop. Now, the first problem is that it's working on their laptop. Fine. Wow, cool. Genius. But the problem is, if I want to see what they are building, or I want to start using that product they are building or that application they are building, the first problem is that I cannot. Why? Because it's on their laptop. Now, that is where, now think about cloud as the guy that now comes and say, hey, I'm going to create a computer that everyone in the world can access. Instead of saying we are using this guy's laptop. Now, let's take this application from this engineer's laptop. Let's ship it to that laptop, okay, that computer that everybody can access. I want to call it a laptop, and that computer is a server. Technically, like a server is nothing but a computer. The only difference is that it's it can be accessed by multiple people. As a matter of fact, there's a local, like your computer is practically a local server that is just only accessible by you. So once it becomes public, it's just like a public server, people can access it. So in AWS, we call it EC2. In Azure, I think it's Compute Engine. I'm not sure. In Google, I think Google is Compute Engine. I'm not sure what exactly it's called in Azure. Maybe Compute or virtual machines. I think so. Correct me if I'm wrong. But yeah. So now, the process of taking it from that computer, from that your engineer's computer, and placing it in a computer that everyone can access is practically the idea of having a cloud service. Now, it gets complex in that. It's not just that. There's so much more to it. There is the part where, okay, now that it's on a computer that everyone can access, so does it now mean everyone can log into that computer and go to like my computer there, or go to the desktop on that computer and do stuff? No. So the only thing you can have access to is what you can have access to. What's the people that are building the platform want you to have access to. And that's the networking part of cloud. And not necessarily networking, but maybe security, like building firewalls against what can be seen or what cannot be seen. But the idea is that everyone can now, the computer can now be transported from that engineer's computer. No, the application can now be transported from that engineer's computer once he's satisfied that this is a great application, it's working fine, I want the public to now see it. Now, it has to be taken from his computer into that public computer that, some set of engineers will come together to build, and then everyone can have access to it. Now, that's an example of what, cloud engineers would do, networking engineers, security engineers, DevOps engineers will also be a part of the process. Now, there's the process of building an infrastructure. That's what they call it. It's an infrastructure. And infrastructure is nothing but like you are building a house. So a lot of concept in IT is very, very they're very, very relatable. They are like common patterns. They are very practical. And that's why I love IT. Like you can try to attribute and create analogies for the things you want to understand. Like understanding different components of that infrastructure, like this application is now in the cloud, which is that computer. Whenever you hear cloud, no, not cloud. Whenever you hear a server, just think about that computer that a lot of people can access. Now, we now start creating different type of rules. These engineers can now say, people from certain part of the world should not be able to access that server. Why? For reasons best known to them, or maybe from government rules. So those are like things that can be restricted by those we call like the security engineers that are working. Like that's practically the job of security engineers. Also, there are a certain part of the application that everyone should not see. People should not, if I am person A, I am using that same computer. Person B should not be able to access my information because the person B has access to the same computer I have access to. So there are like levels of like there are different levels of security maybe at the subnet level. I don't want to go too technical, but at different levels within the infrastructure. So the infrastructure is just a house within it's just a house that would where that computer lives, and then there are different type of barricade, different type of walls, however it's being called technically, that are surrounding it, and then there are definitions of how people can access and what people can do. So there's so much going on, but that's just a high level. Now, there's another part that deals with, of course, I talked about the security part where you create rules of who can access that computer and then where they can access it from, who cannot access it. Those are like things they call like, if it can be security group, it can be like access control. There can be a whole bunch of security stuff going on. I'm not a security expert, but that's like the idea. And there's the infrastructure guy, who can be like an infrastructure engineer or also a cloud engineer, maybe like just engineering the process, developing the process of making sure the application successfully goes from the software engineer's computer into the cloud. Now, the software engineer has no business helping you set that up. His job is to create something and tell you, hey guys, I'm ready. This thing is ready for the world. Just take it. So you can get it from him, and however you want to do it, it's left to you. He has done his job. If anything needs to be fixed within the application, you can talk to him and ask him to do it, fix it, and return it back. And that's another part I'm going to tell you about. So I think I've said something about the idea of a security engineer in the cloud, which is on a high level. And I've spoken about being the infrastructure guy, meaning you are building the house and making sure like it's conducive for the application for the server to be, so people can access the application inside the server easily. And then there's a part of let me see, there's a DevOps part. Now, DevOps, think about whenever the software engineer or the backend or front end guys, whenever they finish building it. Now, of course, it's easy to say, oh, let's just put it in the cloud and then boom, everyone can access it. Now, what happens when there is continuous updates for the application, when things need to change? Now, the Instagram you had 4 months ago is not the same Instagram you have now. You keep seeing like, oh, updates, oh, new stuff is coming up, oh, we have this new feature. How do you think those things come into place without you even knowing they're happening? So that's pretty much what DevOps is about on a high level. So much more to it. But the process of continuously making change in a smooth fashion, in a way that is almost seamless without people even knowing like, oh, an update was made. All you just do is wake up, or just you at a blink of an eye, you just see, oh, it's been updated. How do you think those things happen? The people that are called DevOps engineers. So that's why when people are very new in cloud and they say, oh, I want to be a DevOps engineer, I get scared, because it's not necessarily as easy as people portray. I'm not trying to scare you away, but you really cannot. The first thing you want to be in cloud is probably not a DevOps engineer. You probably want to be like a cloud developer, or maybe not even an architect, but like basic cloud engineer, just to understand the process of, how things go within cloud itself. So you have to be careful about, things you're trying to get yourself into, and understanding like there are certain base concepts you have to understand before you even think about being not even a network engineer, or like a DevOps engineer. So just putting that out there. So now those are like the people that continuously make those updates, that reverting back to the software engineers, like, oh, we need this update, make the update once the software engineer is done making the updates. How do you automatically create a process that just rolls out the new updates? Of course, putting things into consideration like testing, test cases to make sure it's actually working fine. And then now we're ready to actually push the latest one out to the world. And then if that does not work, how do we like go back to the previous one that worked? So there's so much things going on behind the scene that it's a lot of common sense strategy. But when it comes to implementing those things, they can be very technical, but I think it's important to actually understand the idea behind what you're doing in the first place. I think that is very, very helpful. So that's like pretty much what a DevOps engineer do. They deal with like, rolling out those, creating a pipeline or like a seamless process that periodically makes those updates, and without you even knowing something is going on. And there's the data engineering part. Like the data engineering part will be people that handle things like, just getting reports about I don't know how to put it. Data engineering is really wide. You can be a data engineer that focuses on the aspect of just getting huge volume of traffic coming from people trying to get in the application, and you're trying to analyze that, which has a bridge with the security part of cloud too. Because think about it, as a security engineer, you want to monitor like traffic from different IPs or whatever, this is coming from your network, VPC flow logs and all of those. So huge volume of data, and you probably need some level of data engineering skill to navigate, or you team up with a team of data engineers to actually say, oh, we have these logs. How do we filter for what is not what? How do we create certain rules to, make decisions out of what we're getting? So that's for data engineering, a part of data engineering that could have an intersection with security. And there is also the part of data engineering that just deals with Amazon.com, for instance. Like the backend has a lot of data sets from customers. You know how many millions of customers Amazon processes every minute. So think about the process of actually continuously getting information about those data set, and then creating structures for them, and it will be needed by some other team to do some further process too. And that's another thing about IT. IT is a lot of flow going on. something you're doing might be dependent on the next thing another person is doing. So you should always have that in mind, that IT is not just about, oh, you're just doing something and that's it. Like there's always a next step to what you're doing. So data engineers, typical data engineers would be dealing with like processing large volume of data sets, using like virtual systems to like heavy machines that are highly compute process, and GPU engines that are very, very powerful to process large. I'm talking about terabytes of data sets that go on continuously every day. So data engineers will deal with like